Quiz 8 solutions for Math 111. This first problem, we're given a quadratic equation and asked to find all real or complex solutions to it, specifically by completing the square. Okay, when you complete the square, you don't want a leading coefficient of 2, so maybe I'll start by dividing both sides of the equation by 2, so that my leading coefficient becomes 1. And then I don't have a perfect square on this. I don't have a perfect square. X squared plus 2x. If it said plus 1, I'd have a perfect square. Can't just go adding 1, although I could add 1 to both sides of the equation and get here. And the reason you might do that is because then you have x plus 1 squared plus 3/2 equals 1. So if you subtract 3/2 from both sides of the equation, you get x plus 1 squared equals -1/2. Jump up here. So to solve this equation, take the square root of both sides of the equation. And I just have x plus 1 on the left, and on the right I have plus or minus the square root of -1/2. Which used to be a problem, but it's not anymore. This is the square root of -1 over the square root of 2, which is plus or minus I over root 2. Or you could even say it's plus or minus root 2I divided by 2 if you want to rationalize the denominator. So what you get is x equals -1 plus or minus the square root of 2 over 2I. I guess that's all I have to say about that. So there's two roots here. One of them's -1 plus root 2 over 2I. The other one is -1 minus root 2 over 2I. Okay, moving on. Find all roots and the corresponding multiplicities of this polynomial using any method you want. Okay, the way I would do it is I would say possible rational roots are plus or minus 1, plus or minus 2, plus or minus 4, and plus or minus 8. I got that by taking integer factors of 8 and dividing them by integer factors of 1. So I can just test these guys. And as I told you in class, I'm going to make it so 1 or -1 works, so you don't have to test too many of these. F of 1 would be 1 to the 4th power plus 1 to the 3rd power minus 6 times 1 squared minus 4 times 1 plus 8. What I'm saying is it would be 1 plus 1 minus 6 minus 4 plus 8. See, we got positive 10 and -10. That looks like 0. So 1 is a root, specifically a rational root. So 1 is a root and x minus 1 a factor. And now that I know that x minus 1 is a factor, I can use polynomial long division and do x minus 1 divided by x to the 4th plus x cubed minus 6x squared minus 4x plus 8. If I want to get rid of this x to the 4th, I better put an x cubed up here. X cubed times x gives me that x to the 4th. X cubed times -1 is -x cubed. Be careful here. X cubed minus -x cubed is the same as x cubed plus x cubed. This is 2x cubed. Common mistake is to think those cancel out. Now I want to get rid of this 2x cubed. To do so, I'd have to put a 2x squared up here because 2x squared times x is 2x cubed. 2x squared times -1 is -2x squared. And I repeat, subtract. -6x squared minus -2x squared is the same as -6x squared plus 2x squared, which is -4x squared. To get rid of this, man, I'm going to run out of room. -4x squared, I better put a -4x up here. -4x times x is that -4x squared that I was hoping for. -4x times 1 is positive 4x. And if I subtract, I get -8x plus 8. To get rid of that -8x, I put a -8 here. And sure enough, if I multiply that by x minus 1, I get -8x plus 8. So I get no remainder, which is a good thing. That tells me that my polynomial is x minus 1 times x cubed plus 2x squared minus 4x minus 8. And I can now factor x cubed plus 2x squared minus 4x minus 8. 4 terms, I'll try factoring by grouping. I think that'll work. From this first group here, I can pull out an x squared that's the greatest common factor and be left with x plus 2. If I want to be left with x plus 2 over here, I better pull out a negative 4. Now I have two terms that both have an x plus 2 in them. So if I pull that out, I get x plus 2 times x squared minus 4. X squared minus 4 is a difference of squares, so it can be factored to x plus 2 times x minus 2. What I'm trying to say is that f of x is equal to x minus 1 times x plus 2 squared times x minus 2. So it's asking me to find roots and multiplicities. The roots would be 1, negative 2, and 2. And their corresponding multiplicities would be 1, 2, and 1. Hopefully you know what I mean when I write all that. I could even do this if it makes it more clear, although I'm afraid that that makes it less clear. Whatever. Alright, now that I have all this information, it says draw a picture of your function. Whew. Okay, so the y-intercept should be 8, because when x equals 0, y equals 8. 1, 2, 3, 4, 5, 6, 7, 8. It better go through this point right here. And behavior. Leading coefficient positive. This is an even number, so it's going to go up when it goes to the right and up when it goes to the left. My roots are at 1, negative 2, and positive 2. Here's 1. Here's negative 2. Here's positive 2. However, the multiplicity on the root at negative 2 is even. So the graph's going to kind of come down here and hit this point and bounce off. Whoops. Turn around. Head up like this and go through this point. And it's going to head right back down here. Make sure it gets through this point. Turn back around. Whoops, kind of missed that point. All right, let's try that again. I'm just going to start from scratch. I don't know if this is going to be any better, but it bounces off here because the multiplicity is even. At some point it turns around and goes through our y-intercept. And it goes through that x-intercept, goes right through it because the multiplicity is odd. Same with this root here. And what you'll notice, I have the proper end behavior. It's going up on either side. So what I have is a very, very, very rough sketch of this polynomial. And what I also have is the end of this quiz.